So we cannot use ordinary least square like we have used it for multiple linear regression. Now what is the way out for logistic regression where your dependent variable is categorical? Now statisticians have come out with this. We can't use a linear function to estimate the parameters of logistic regression because y here is categorical variable. Now they come out with some function thanks to statisticians. That function is called as sigmoid function, right, or also known as logistic function. So what is the significance of this sigmoid function? Have a look at this. So this is in effect a sigmoid function. The equation for sigmoid function goes something like this: pi of z is equal to 1 divided by 1 plus e power minus z, right. For particular value of z, if you keep on plugging in the data, the sigmoid function produces this elongated S curve. What is the significance of this elongated S curve? If you look at it, the maximum and minimum value for this lies between 0 and 1, right. So when you keep on adding the values of z, then accordingly we get this elongated z curve, but this never crosses, that means goes below 0, right. If you look at this part of the tail part of it, it never goes below the 0, and the top part of it, right, so it never goes beyond the 1. So at 1 it gets attenuated, and 0 it gets attenuated for various values of z, right. So essentially values of z can be minus infinity to plus infinity. So values of z can be minus infinity to plus infinity, but whereas pi of z value will always remain between 0 and 1, right. So here also if you look at it, our categorical variable is having two classes, has 0 and 1, right. So now they have understood that, so the boundary conditions of 0 and 1 is satisfied, and also I have a continuous function in terms of sigmoid function, right, and hence they have identified sigmoid function to be appropriate function for decoding this relationship between a categorical dependent variable and numeric or non-numeric independent variable. The equation of pi of z, which is equal to 1 divided by 1 plus e power minus z, the variations of it also you will see in very many books, which is basically e power z divided by 1 plus e power c. Both these things, as you can see, are similar, where here e power minus z is expanded and then simplified like this. So this is also same and this is also same. So the point to be taken from here is, in order to establish a relationship between the categorical dependent variable and the independent variable, which can be metric or non-metric, we cannot use ordinary least square method, or we cannot use a linear function to define it, and hence we went for what is called as sigmoid function. Moving on. So the logistic or sigmoidal function, now whatever we are going to talk about is based upon the sigmoidal function. So let us spend some more time on it. So pi of z is nothing but probability of y is equal to 1, that is probability of what we call it as success class. So that means the pi of z essentially gives me what? The pi of z essentially gives me a probability value, right? Probability value for the success class it gives. So again, pi of z is equal to 1 divided by e power minus z, which can be further expanded into e power z divided by 1 plus e power z, where z is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus so on and so forth up to beta n xn. If you recall, it will ring a bell, this is the equation for multiple linear regression as well. So that means what? So whether z is a linear function, in this case z is a linear function, but the sigmoid function is not a linear one, right? It is not a linear one, right? So this is the relationship that we need to understand between the sigmoidal function and how we are converting the z into a linear function. Now moving further, couple of points you need to understand from this equation above. Let us call it as the equation 1. Here y is a categorical variable in the logistic regression, where y ranges between or takes a value, two values, either it can be 0 or it can be 1. Please understand that. Actually, if you look at it, what it is basically a conditional probability of event y is equal to 1, right. This pi of z is nothing but conditional probability of event y is equal to 1, or put it otherwise, probability of success class for the given independent variables, that is xi's, right. For the given xi's is nothing but your independent variables, right. Understand this is how the sigmoid function needs to be understood. Moving further, probability of y is equal to 1 for various independent variables, right, for the given the x, right. So this is called, needs to be read as given. Probability of the success class given these independent variables, pi of z is nothing but exponential of alpha plus beta x. So this is z, right, whereas z is equal to beta naught plus beta 1 x, that is what we have seen. So instead of beta naught, here we are using alpha, right, just to differentiate is a intercept, and beta is the regression coefficients. So exponential of alpha plus beta x, which is nothing but what we have already dealt, right. So this is the one that is getting expanded. So exponential of alpha plus beta x, beta into x divided by 1 plus exponential of beta plus x. How to interpret this? This is the logistic regression, right, logistic function coefficient, right. If b is equal to 0, that is beta is related to the regression logistic regression model, where b is related to estimates, right. So we will come to how to estimate. So in this case, if b is equal to 0, that is the coefficient of x is equal to 0, so that means what, the probability will remain same for all values of x, there will be no change in the probability. If b is greater than 0, if you substitute, what it implies is the probability increases as the value of x increases, that is per unit change in x, so on and so forth. If beta is less than 0, implies that probability will decrease as the value of x increases. Any value of x, the positive value you put it, then even beta is negative, that is b is negative less than 0, it implies the probability will decrease. So it is easy to remember in terms of interpreting the coefficient. If the beta value is 0, probability remains the same. If beta value or b value is greater than 0, the probability increases for every increase in x, that is your independent variable. If probability beta value is less than 0, that is negative, we have a negative coefficients, then the probability of the success class decreases for every increase in your independent variable value. So this is the way that you need to understand. Obviously, what is b? B is the estimated coefficient of age of x, right. So in this case, we are taking y as a disease, that is your dependent variable as disease, whether you have it 1 or no as 0, and then y is related to age or not, is what we are trying to understand, right. So we can calculate, we can understand beta as the coefficients of age. So now at the end of it, this is the equation, you will get it, right. So if you substitute the respective alpha value and beta value, you will be getting the probability value, right. So for various value of x, which is your age, what is the probability of disease you will get. So at the end of it, logistic regression will nicely give you the probability value for every change in the independent value.